Alright friends, so now let's say that you have created your indexes in your database and your query is optimized and you have fast performance, but the job is not done yet.
No, God! No, God, please, no! No! No!
Because over the time the indexes get fragmented, outdated, unused, and this gonna lead to a poor performance in your queries and as well gonna increase the storage costs and the overall performance of your database gonna drop down. So indexes like having a car, it needs maintenance, so you need to change the oil and the tire of the car. And the same thing goes for the indexes. You have to maintain them, they need attention to keep everything running smoothly. So now I'm gonna show you how I manage, maintain and monitor the indexes of my SQL project. So let's go. The first and the most important task is to monitor the usage of your indexes. So of course the first question we have to ask ourselves, over the time, are we using really the indexes that you have created? Are they really helping improving the speed of my queries? Or was it just a good idea at the start of the project and later no one used those indexes? This is very crucial because if you are having an unused index, you are consuming unnecessary storage space and as well the write performance in the tables gonna be slow, which is completely unnecessary if you are not using the index. So now our task is to find out the usage of each index that we have in the project. So let's see how we can do that. So now previously we have created like multiple indexes on the table DB customers. So if you go to the DB customers and to the indexes, you can see that we have 4 indexes. Now you can go and show those informations by using a special stored procedures from the SQL server called SP help index. Let's go and do that. So SP help index. So it is a system stored procedure that comes with the database. So this stored procedure needs only one value and that is the table name. So we have it over here, sales DB customers. Let's go and query it. So we have 4 indexes, then we have a nice description of the index. So it says it is non-clustered index and whether it is column store, and it says where it is located. So it says it's located on primary. Primary is the name of the file group where the data is stored and as a default can be stored as primary. And now the next information, we have the index keys. It is nice information to understand which keys are used or which columns are used for the index. So the first one you can see we have 2 columns. That means it is a composite index. And of course for the column store we don't have any columns and then we have the first name, last name. So this is a really nice quick stored procedure in order to see information about our index. Okay, so now let's focus on our task on how to monitor the usage of the indexes. Now in databases we have a lot of schemas and tables that protocol the metadata of our database. And in SQL Server we have a special schema called sys where you can find a lot of metadata information about the SQL Server. Metadata like the description of the tables, views, columns and as well the indexes. So now let's check what we can find inside the table indexes. So let's go and do it. Select star from sys. This is the schema name. And then as you can see, we have a list of many informations, but we want to focus on the indexes. Now let's go and execute it. Now we get a huge list of all indexes that we have and a lot of informations for each index. We don't have to go and understand now each column, but I'm gonna go and select the main important informations from this table. So what do we need? The object ID. This is the table ID. So the object ID. And we have the name. It is the index name. And then here we have a nice information whether it is clustered or non-clustered. So let's go and select it. Type disk as. So let's call it index type. And we can go and check whether it is primary key or not. So let's get this information as well. Is primary key. I will go and just rename it is primary key. And what else do we need? Whether it is unique. So it is as well nice information to have. So is unique. So of course you can go and grab a lot of stuff. It depends really on what you are monitoring. So for example, I'm gonna go and check whether it is disabled or not. So is disabled. And I'll just rename it. So with that, I have like focus monitoring. I don't have to have all those informations. So let's go and execute. But now I would like to go and change few stuff. Like for example, I don't want the object ID. I would like to have the full name of the table. And as well, there is a lot of indexes that is irrelevant for my database. So now in order to do that, you have to go and get the informations from another metadata table. So let's go and call this index and let's go and join it with another metadata table. It's called tables. So TBL, and we're gonna go and join it using the index object ID equal to the table object ID. And now if you'd like to see the content of this table, we can go and create it separately. So select star from our new table. So let's see the content of this table. So you can see we have the name, which is the table name. And I think that's all what we need. We have a lot of other informations about the table. Well, I just need the table name. So let's go and do it at the start. TBL name as table name. And I don't need anymore the object ID. But of course, we have to go and use the alias for each of those informations in order to understand those informations comes from the index. So let's go and do that. All right, so my query is ready. Let's go and execute it again. So now as you can see, we are getting the table name and the list is very short because it is only focusing on the tables that you have in the database. And this filter happens because of the inner join. But one more thing, I would like to go and sort the data. So I'm going to say order by. I would like to sort it by the table name and then the index name. All right. So now let's go and check, for example, the table customers. You can see that we have two non-clustered index and one of them is column store index. Those two we have created from the previous tutorial. And we have an index on the primary key. As you can see here is primary key equal to 1. And this is as well unique. So with that, we have a really nice list of all indexes that we have in our database. But we are not there yet because our task is how to monitor the usage of the index. Now, in order to get the usage for each of those indexes, we have to go to a special view called Dynamic Management View. And there the SQL Server can provide a lot of statistics about the usage for the index. And we can find it as well in the same schema. So let's go and query this table. So it's going to be select star from. So the same schema sys.dm underscore db underscore index usage stats. So let's go and explore this table and execute it. Now in those statistics, we can find the usage of two indexes, the index number 3 and 1. And we can see there are like 3 usage informations of the index number 1. And next we have like user seeks, user scans, and user lookups. So this is how many times the index is used as seeks or scans or lookups. We will understand those informations as we learn about the execution plan. And here we have a very nice information about how many times our index got updated. So as you can see here is 0 because I didn't add any new data after creating the index. But of course all those numbers might be different at your side because it depends whether you are doing more queries and practicing. And you can find here more information about when was exactly the last usage of those indexes and many nice informations. So now let's go and integrate this view with our query. So now what I'm gonna do a left join because if I do an inner join, I will only find the used indexes. But I don't want that because I want to see a full build of all my indexes in the database. So left join, and we're gonna go and get our view and call it S, and then we have to join it on the keys. So S on. So I would say let's go and grab the object ID equal to the index object ID. And of course we have to join on the index ID. So it's gonna be the index ID equal to the index ID. Like this. Now we have to go and select few informations from this view. So I'm gonna go and select like all those number of usage. So S. Let's get the user seeks, S, the user scans, and the lookups. And maybe as well the user updates. And it is really nice information to understand when it was the last time used. So last user seek and the last user scan. Let me just correct it over here. And actually I can go and put those two dates in one date because if it's like the last seek, it's going to be null over here or the opposite. And now what we can do, we can go and put those two together actually in one column because when we have a value over here, it's going to be null and vice versa. So we can do that using the null function kawalis. like this, and we can get this over here, and we can call the whole thing last update. So like this, and maybe I'm gonna go and rename all those stuff. Alright, so now we are done. Let's go and execute it. Okay, so let's go and check our new report over here. So this is our query. And let's start with the first table, for example, the customers, and go to the right side. And now we can see that we have 3 indexes. And from these 2 indexes, we have only one index that is not used at all. So we can see over here that the non-clustered index on the country is not being used, and that's because we have another index about the country that comes from the column store. So it could be like this, that you are querying the table using the country, but the SQL saying I would like to go and use this index instead of the first one. So we can say, okay, this one is not really useful, maybe we can go and drop it, right? And for the rest you can see, okay, this column store index is used twice and the next one is once. Again, the numbers at your side might be different. And if we have a look to all other tables, we have a lot of nulls. So that means all those indexes that you have created on the DB customers, let me check, only one is used. But now you might say, you know what, I've used the index, but why I'm not seeing here any numbers about it? Well, that's because those numbers will not live forever, and we are using now the Express edition locally at our PC. So each time you shut down your PC and you close the client, the database is gonna shut down as well, and those statistics gonna be lost because they are in the memory. But in real projects, the numbers gonna be totally different than here, and of course you're gonna get realistic numbers. Now let's try to target one of those not used indexes. So for example, let's go with this index. It is not clustered index on the product. So let's go and query that. Currently it is completely not used. So if I go and select it, so select star from sales products, where product equal to caps. So with that, we have used the index, I think. Let's go back and query again. And let's go to our index and check whether it is used. Well, it is correct. So our query did use this index, and we can see here it is used once. And now you can go and analyze in your project all the indexes that you have on your tables, and you can see whether you are really using it with your queries or not. And if you are not using the query, of course, you have to make a decision about it. Maybe if you are working in a team, to ask about it, who did create it and why. Maybe there is like one task in the database that is not frequently used. Maybe it's something that is run like once a month or something like that, so the index is needed, but not that frequently. But still now we have like insights about what is going on with those indexes and whether we need them or not. And if you don't need them, go and drop them. Alright my friends, so here is the secret that 90% of SQL developers don't do that's gonna make you in 1 minute the hero of the project. So once I join a project and after saying hello to everyone, I open the database of the project and do one query. I check the usage of the indexes of the project. And I can tell you after working 15 years with SQL that 90% of indexes created in projects are totally untouched and unused. So I collect all unused indexes and discuss it with the team. And if we don't find a real usage for those indexes, we go and drop them. So after dropping all those unused indexes, you have done 2 great things for the projects. First, you have saved a lot of storage in the database, and second, which is way more important, you have improved and optimized the right performance on the database. So in your first day with one query, you have optimized the performance of the database, you have saved storage, and you're gonna shine like an expert in your project. So if you haven't done that, do that now. Alright, so now moving on to the next one. As we learned, identifying an unused index is an important task, but in the other hand, identifying a missing index is as well very important to improve the performance of your queries. So in SQL Server, you can get recommendations from the database itself about missing indexes for your query. So let's see where we can find those recommendations. Alright, so now let's say that you are doing multiple queries and you are doing analysis and so on. For example, I have this query over here. It is query on the database AdventureWorks DW, and I'm joining just 2 tables, the fact with the dimension, and then filtering the data based on the colors and as well on the the date key, where I have like a range over here. So once I executed, I got the following informations. It could be any query that you are doing while practicing and analyzing and so on. So now if you have like slow query and so on, you can go and check the recommendations from the database about missing indexes. So in order to do that, we can go and check again the metadata from the database system to see the recommendations about the missing indexes. So let's go and do that. So we're going to go and select from, and now we have to go and target the dynamic management views, and it is like this: dm_db_missing index details. So let's go and explore the content over here, and don't forget that those information is gonna be inside the cache of the server, and if there's like a restart or something on the server, you will lose all those informations. So now from my query there is few suggestions and recommendations from the database. Let's go and check it. So we can see here there are 4 recommendations about missing indexes from the database. So now let's go and check the first recommendation over here. You can go and check the table name from the object ID, or you can find it here in the statements. So here the database is suggesting an index for the table dimension product, and it is recommending us to make an index for the column color. And that's because if you check our query, we have like here a filter, the where condition, where we are seeing the color equal to black. And since we don't have an index on the color, SQL is just suggesting to use an index for the color. And of course, in this situation, we can go and use a non-clustered index. Now, after that, we have 3 recommendations for the same table, fact, internet, sales. So for example, here it is suggesting to make an index on the order date key because we are using it in the filter over here, and as well suggesting to make an index for the product key since we are using it for the join. So this is really nice report about missing indexes in the database, and it could assist you to find out things that you didn't thought about. But here my recommendation is evaluate those informations very carefully. Don't go and create like an index for each suggestions from the database. You still have to think about it. Is it really necessary? Do we really use this query very frequently, and so on? So don't go blindly creating indexes for each recommendations from the database. So this is really nice tool and assistant for you in order to make a good strategy for your indexing. So this is how you find the recommendations of missing indexes from SQL database. Okay, so now to the next step, we have to go and monitor the duplicates in indexing. If you are working in a team with multiple developers and you are working parallelly in order to optimize the performance of the queries, what might happen is that different developers creating different indexes for the same column in the same table. But of course, this must not happen if you have a clean and solid review process in the project. But we are human and those things could happen, so that's why you have to monitor whether there are like duplicates. So the mission is to find whether there is a column that is involved in multiple indexes. So let's see how we can monitor that in SQL. Okay, so now it's very simple in order to find the duplicates of indexes inside your database. So we have learned before that we can find a list of all indexes in this table, indexes, in the system schema, and then we join it with the tables in order to get the table name. And then we have another table in order to find the columns that are involved in the index. Those informations, we can find it inside the index columns. And now in order to get the full name of the columns, we're going to go and join it with the columns table. So it's very simple and makes sense. Let's go and execute the whole query. Now, as you can see, it is sorted by the table name and the column name, and that's because we can find then easier the duplicates. So let's go and check the first table. So the country is part of this index where we have the column store non-clustered, and again the country is involved in another index where we have the customer's country, and this is a row store non-clustered index. So this is of course bad thing. We have to go and decide now, do we want it as a column store or a row store? And if we check as well this table, we can find the first name in 2 different clusters, the same story, and that's because we were practicing and creating those indexes, and that's it. But now if you have like large schema and a lot of indexes, I would go and make like a flag in order to understand whether we have a duplicate or not, and that's by calculating the number of rows of unique table name and index name. And we can do that very easily using the window functions. So let's have a new row, and we're gonna go and use the function count since we want to find the number of rows over. Then we're gonna go and partition by. We need the table name and as well the column name. our expectation of this column should be 1. If we have more than 1, then there is an issue. And that means the column is inside 2 different indexes. And now let's go and sort it by the column name and descending. So let's go and execute it. And now we have here a nice flag where we can see how many rows we have for a specific column in a table. So if it's 1, like those columns, they are fine. Those columns are involved only once in one index. But for the first 4 rows, we have here an issue because we count here 2 columns. That means we have 2 indexes for the same column. So as you can see, the query is very simple, and with that we have a nice report about the duplicates of indexes inside our database. Okay, one more thing in order to maintain our indexes is by updating the statistics. The database engines usually use statistics in order to understand which index should be used for our query. And if these statistics are not up to date, SQL gonna make wrong decisions. So let's understand what this means. Now let's say that you have created a table and you start inserting data to this new table. Now the database engine gonna go and create your new table and insert the data. Behind the scenes, the database engine gonna go and create for your new table statistics. It's like metadata informations about your data. And that's like a report or insights about your table, where you can find a lot of informations like the number of rows, the distribution of values in a column, and as well we can find the number of distinct values and histogram and patterns and many other informations about your table. So now of course the question is, why do we have those informations in the database? Now imagine that you are doing select from where. What's gonna happen, the database engine has to go and create an execution plan. We're gonna learn about this later in details. It is just a roadmap on how to execute this query. So here for example, in order to load the data from the table, there are like different ways on how to do it. So there is like a table scan, index seek. So that means the database engine has here 3 different ways on how to do it. And now in order for the database to decide which way to use, it's gonna go and read the statistics of the table. So it's gonna go and collect informations. Okay, how many rows do we have? Are the informations are unique? How is the distribution of the data, and so on. And now based on those statistics and numbers, the database can now make a good decision about which method to use in order to load the data. So for example here, the index scan is the best way to load our table. So this is exactly why the database needs the statistics in order to make the correct decision and to use the correct index. So now you might ask, okay, this is something internal for the database. Why do we have to care about it? Well, there is an issue. Now, for example, in our table, we have 50 rows. And let's say that in the next day, you went and inserted to this table like around 1 million row. Now, the issue that could happen is that the statistics will not get updated about this table, and the statistics can still say that we have only 50 rows. So that means the statistics of this table is now outdated. And the big issue is that once you query this table, the SQL engine don't know at all about the 1 million row that you have inserted in the table, because it's gonna go and ask the statistics and it's gonna answer with only 50 rows. And the database is gonna say, okay, this is very small table, and let's maybe skip an index or something. So that means the database can make wrong decisions because the statistics are outdated. And now your task is to monitor those statistics and to keep updating them. So let's see how we can do that. Okay, so now the first thing that we have to do is to find out whether our statistics are up to date or outdated. In order to do that, we have as well to access the metadata about our database. And for that as well, we have tables and dynamic management functions in the system schema, where we can find a lot of details about the statistics. And in order to monitor the statistics, I have prepared a query like this. So here I'm using a table called stats, where here you're gonna get a list of all statistics inside our database and the name of the statistics. And then I'm joining it with the tables in order to get the table name. And what is very important is the dynamic management function. So here we're going to get very important informations like the last update and the number of rows and the number of modifications. So let's go and query it. So here we can see informations like the table name, the statistics name, and now it's very important when the last time the statistics get updated. So now let's go and check our table DB customers. We can see here the statistics name, and what is very important is the last update. So this tells us how old is the statistics. So for me it is like 4 days, and then we can find the total number of rows in this table. And now what is very important is the number of modifications that have been done on the table. So after updating the statistics on the 19th of October, there were around 15 rows that got modified. This could be an insert, update, delete, so any operation on the table considered to be a modification. So with that you can see there were a lot of modifications, so these statistics should be updated. So now for the table customers you can see that the statistics are up to date, so we have here 0 as a modifications, and there will be no need to update the statistics. So this is how you can go and check the statistics informations inside your database in order to make a decision, should I update the statistics or not. So now let's say that I would like to go and update the statistics of our table DB customers. Now as you can see we have here multiple statistics. So over here we have these statistics on this table, and as well we have the statistics on the index. So as you can see, we have here multiple statistics in one table, one for the table itself and one for each index that you have in this table. So now let's say that I would like to go and update the statistics only for one. I don't want to update everything in this table, only for one statistics. Let's go and do that. So it's going to be very simple, update statistics. And then we have to go and mention the name. So it's going to be sales DB customers. And then we have to specify the name of the statistics. So let's go and get this over here and let's go and execute it. So it was very fast. Let's go and re-execute our query and check the data. So now let's go and find it. It was exactly this one. And as you can see, it just got updated and the number of rows is 5 and the number of modifications is 0. So we have now an up-to-date statistics for this table. But let's say that I would like to go and update the rest, but I don't want to do it one by one. So what we can do, we can just copy the same thing over here, but we don't specify any name of the statistic. So we are saying update statistics and then only the table name. So let's go and execute it. So now what's going to happen is SQL going to go and update all the statistics that belongs to this table. So let's go and check our query again. Now you can see everything disappeared and the DB customer is completely up to date with no modifications problem. So this is how you can go and update your table, and you can do then for the rest as well. But now there is like one more thing where you can go and update the statistics of the whole database. But beware, this might take really long time. And we're gonna do that by executing a special stored procedure. So execute sp update stats, this one over here. Let's go and do that. And now it is done, and we have here a pretty long log. It was fast because we don't have a big database. It is very small database, so it's not compared to any real databases. So now you can see over here that SQL is going through everything that you have in the database and trying to update the statistics. So in many situations, it's going to be not necessary because there is nothing to update. There were no modifications and so on. That's why the database is smart enough to say, no, it is not required, and it go and skip it. So now how I usually do it in my project is that I have like a job on the weekend where it's gonna go and update the whole database statistics. So with that, I make sure all my tables and indexes having up-to-date statistics. Of course, if you have a small database, you can run this like every day. But if this takes a long time, then you can schedule it in the weekend. And as well, if I know in the project that there will be in one day a lot of new incoming data, so we are doing some kind of data migrations, so I go and update the statistics after the data migration is done, just to make sure we have up-to-date statistics. So this is how we monitor and update the statistics of the database. Okay, so now moving on to the final task that I usually do in order to monitor and manage the indexes is to monitor the index fragmentations. Over the time as your data is inserted, updated, deleted into your tables, indexes can become fragmented. So what is fragmentation? It means like there is unused spaces in your databases and the database is not filling them, or your data is not anymore sorted correctly in the index. And this of course leads to inefficient use of the storage and as well gonna slow down your queries. And in SQL, in order to get everything organized again, we have two methods. The first method is reorganize. So it's gonna go and defragment the leaf level of the index in order to get it organized and sorted again with the logical order. So it is very light operation and it will not block the user from using your table. And the second method called rebuild, this is heavyweight operation. It's gonna go and drop the whole index and recreate it from the scratch. And this means, of course, not only the data gonna get sorted again, but as well the fragmentations inside your databases and the index gonna be eliminated. So let's see how we can do that in SQL. Okay, so now back to our database, and the first question that you have to ask, do we have an issue with the fragmentations in our indexes? So we have to check the health of our indexes in the database, and in order to do that, we have again to go to the system metadata that we have, and we're gonna check their dynamic management functions. So there is like special functions in order to get an answer in the SQL server. Let's go and do that. So we're gonna go and select star from the function. So it is sys dot, so it's gonna be sys.dmdb index physical states, this one. And this is a function that we have to pass few parameters. We will not go in details, just follow me with this. So we have to give it the db id and a null, another null, and a third null, and the last one gonna be limited. So we have to do it like this. So let's go and query it. Now what do we find? We have the object ID, we have the index ID, and few other informations, but the most important one is the average fragmentation in percent. So this column gives us the degree of the fragmentations in our index. If it is 0, then it is perfect. We have no fragmentation in the index and our index is very healthy. But if it is like 100, then that means it is completely out of order and we have to do something about it. And now you might say, you know what, I don't know which object is that and which index. Well, you have to go and join few tables like the sys.tables and sys.index in order to get those informations. So we have to go and do that like we have done the first query. So, okay, so offline I have done that. So I joined with the tables and the indexes and I'm sorting the data by the average fragmentations as percentage descending in order to get the problems at the start because we are interested where we have high percentage. So let's go and execute this. And now since it is practicing database, I didn't insert any data and so on, but in real projects you will get here different numbers. And here is my recommendations about the percentage. If the fragmentation is between like 0 and 10, that means everything is like okay and you don't have to do anything about it. But if the percentage is between like 10 and 30, then here we have to do something about it. So here I recommend to use the reorganize method in order to sort the data again correctly. But if you have more than 30%, then here my recommendation is to go and rebuild the whole index. Because not only the data is in wrong order, but as well there is unused spaces in your database in the index. So you have to do something about it. So now let's go and imagine one of those indexes, for example, this one over here has fragmentation of 15%. So now what we have to do is to go and reorganize this index. Let's see how we can do that. So let's go over here and say the following, alter index, and then we need the index name. So let's go and get it from here. And then you have to mention the table name where the index exists. So we have it from the customers, so from sales customers. So now we are editing the index and we have to tell SQL what to do now. So we just want to reorganize the index. So you go and use the keyword reorganize. So reorganize. And that's it. This is very simple. So let's go and do that. And as you can see, it is completed and it was very fast because we have small database. But sometimes it takes a little more time if you have a big index and big table. So after reorganizing, you can go and again check the table over here and see the results. And it should be like here is 0. Now let's say that we have another index where the fragmentation around like 50%. So let's go and copy it, and this time instead of reorganize, we're gonna do rebuild. So I'm gonna take the whole thing, and this time we're gonna go and rebuild this index over here on the same table, and instead of reorganize, we're gonna say rebuild. So let's go and execute that. And with that, SQL did drop the whole index and create it from the scratch. And this is usually takes more time than reorganize, of course. And the next step, of course, is to go and check again the fragmentations and so on. So that's all about how to make your index healthy and remove the fragmentations from your index. Alright my friends, so as you can see, improving the performance of your queries doesn't end by creating them. It's all about staying proactive. So monitor the usage of the indexes, check whether there are any missing indexes, and always make sure the statistics of the database are up to date, and keep your eyes on the fragmentations and make sure you have healthy indexes. So with that, you have learned how I manage and monitor the indexes once I create them, and I really recommend you to follow those steps. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.